partners in this talk, and in the last 10 years to evaluate and rehabilitate Cisco in Lake Ontario. They're formerly called Lake Herring, but now the right term is Cisco, which is the Coregonus artidae, for those taxonomists in the room. So as I said, a great partnership here from USGS, DEC, OMNR, Cornell University, the Nature Conservancy, and the Fish and Wildlife Service, and also a new partner has joined us, Queen's University, and I'll be talking a little bit more about their upcoming work. So I want to just touch on the status and distribution of Cisco currently in Lake Ontario, get into some restoration stocking that we've conducted in recent years, and then just touch on some current research and some new research directions from where we're headed. So Cisco and chub were very important. That they were the main prey fish in Lake Ontario in the late 1800s and early 1900s. There was actually a commercial fishery for them. This is data showing those commercial catches in thousands of pounds. And as you can see, by the 1950s, those populations were depleted, probably due to fishing, but also impacts of invasive species. The data we have, though, are Cisco, artidae, combined with what was called chub. They really didn't distinguish between the two. But originally there were 3 deep water forms of Cisco, short nose, kai and hoyi, and then artidae is our shallow water form, which are really the only fish, the only species left in the lake, or the shallow water form. So some more recent data we have, the USGS and DEC conducts trawling every year since the late 70s. Ontario has a small commercial harvest, commercial fishery there, and then MNRF also conducts gill netting every year to assess the status of Cisco in the Eastern Basin and the Bay of Quinte. And you can see the trends track each other fairly well, with higher populations in the 80s and 90s, a decline through the 2000s, and then a recent increase in 2015. Some data on some trawling that Jim Hoyle conducts every year in the Eastern Basin. We think this represents a good index of year class strength. These are YOY catches per trawl, and as you can see, in more recent years, for Cisco anyway, we've had some good year classes recently. I include the lake whitefish as a contrast. As you can see, in the 90s, there were good catches of whitefish, now less so. And what the mechanism there is that seems to be favoring Cisco now versus whitefish is sort of an interesting question for us. But overall, Cisco seem to be producing in recent years. Cisco distribution in Lake Ontario. Cisco are mainly isolated to the Eastern Basin. This is the distribution of all the USGS DEC trawling sites. The western sites are on the left, the eastern sites are on the right, and most of our catches occur in the Eastern Basin, but there is some small catches in at other sites around the lake. As far as spawning distribution in Lake Ontario, we know the red dots represent places where we know spawning occurs in Chameau Bay and in Bay of Quinte. Jim Johnson, back in the 2000s, conducted some work where he looked at distribution of larval Coregonines in historical sites across the eastern and southern shore of Lake Ontario. That's where the yellow dots represent. And the only places where he found larval Coregonines were Black River Bay and Chameau Bay. All of those other sites, he found none. And then more recently, the Nature Conservancy has joined our efforts and evaluated Irondequoit and Sodus Bay by setting trap nets looking for spawning adults, and also conducted some larval trap sampling, and also found no evidence of Coregonines there. We know in Chameau Bay that we do catch spawning Cisco. Johnson Shoal, the red pin there, is probably the most important site, but there are also other shoals in that bay, and I'll talk a little bit more about that in a minute. So based on the information that we have, it seems like the only places where Cisco are currently existing for spawning are the Eastern Basin, Chameau and Bay of Quinte. So what we'd like to do is expand those spawning populations, and in 2011 we started to collect spawning Cisco and take eggs from those fish, and then transport those eggs down to the USGS in Tunison, where Jim Johnson and his crew have developed culture techniques to hatch and grow Cisco quite well now. And then those fish are transported to Irondequoit Bay and have been stocked as fall fingerlings or close to yearlings. Some of the stocking occurs in September, and some of it closer to November, which they would be yearlings then. And this is the stocking that he's conducted since 2012, totaling about 250,000 now. In 2015, there's some surplus were stocked into Chameau Bay as well. So as a way of building hatchery capacity, the U.S. Fish and Wildlife Service has recently committed to dedicating some resources and hatchery space to culturing Cisco. And this is in last fall, some USGS or some U.S. Fish and Wildlife Service staff joined USGS in working together and getting some training on techniques for taking Cisco and then culturing those fish. So I just want to switch to some research directions for Cisco. And in 2004, John Fitzsimons and Bob O'Gorman published a workshop proceedings that is really acted as a good guide for laying out some direction for research, including looking at spawning habitat and population characteristics, looking at the factors for successful reproduction of Cisco, including habitat quality and perhaps predation on eggs and fry, conducting restoration stocking, and then looking at the genetics of Cisco. So to start off, we have been looking more closely at the population characteristics of spawning Cisco. This is some data that we collected this year in Chameau Bay with USGS and Fish and Wildlife Service's help. And you can see most of the fish in this year's spawning population were age 3. And if you go back to that graph that I showed before of the year class strength from the Oman trawling, in 2012 there was a strong year class, and apparently they're now showing up as spawning Cisco in Chameau Bay. But the majority of the fish that Jim actually took to the lab and spawn were age 5 through 10, and then as high as age 12. Some work that Ellen George has conducted for a master's degree, along with Lars Rudstum and Darren Crabtree from the Nature Conservancy. She looked at Chameau Bay and tried to determine where these fish were spawning. We knew Johnson Shoal was an important spawning location. This is where we've conducted trap netting for 10 years, but we really have never definitively shown that these fish are actually spawning there. We know we can catch them with our trap nets. So as part of her work, she went out and actually did some egg pumping to look at where Cisco eggs were and where they weren't. And what she found is that the eggs were heavily associated with rocky shoals, including Johnson Shoal, but also at Herrick Shoal and Middle Shoal. The green dots show where she caught fish. The black dots show where she did not. And most of those black dots are in areas where there's silt or soft substrate. The rocky habitat seems to be the best, seems to be where these fish are concentrating their spawning. She also conducted some where she laid egg mats, and she found densities as high as 10,000 eggs per square meter. U.S. Fish and Wildlife Service has since come in behind that and done some side scan sonar and some substrate mapping, and this is a map showing that. I tried to kind of twist it and rubber sheet it to show you where it was in correspondence to her work, but essentially when you do that, it lines up pretty well. The fish were spawning on Johnson Shoal, and the places where she found eggs is that rocky habitat, and the soft substrate where the purple is where she either did not find eggs or she found dead eggs. The U.S. Fish and Wildlife Service and USGS and Cornell have recently taken on a project where they're supported through GLRI, where they're working in Thunder Bay, Lake Superior, where there's a sustainable population of cisco, and they have plans to not only look at identify the places where cisco are spawning, but also look at the habitat and the habitat quality of that location, and then try to take that information and the information that we gain from Chameau Bay and apply that to historical places where cisco used to spawn to assess the habitat quality in those embayments. Ellen's also done some larval cisco work where she looked at cisco and whitefish distribution in Chameau Bay. She collected larvae in the spring and then tried to identify those fish first with heuristics and just taxonomy. She found that it was very hard to do. There's a lot of overlap between cisco and whitefish, so she used genetics to try to decipher the two, and she found that 80% of the larval cisco had the potential to key out as lake whitefish. But what she also found was that the majority of the fish, the larval fish that she was capturing with her Newston nets, were cisco in Chameau Bay, which is contrary to what Jim finds with his sampling, where he's seining along the shoreline. And they've also done some pelagic sampling where most of the fish that he was catching were lake whitefish. So we're still working on that question and trying to figure out what's going on there. But it might be just a matter of distribution and timing. Just touch on briefly, there's a new project. Bruce Tufts of Queen's University has this acoustic array set up. Each of the stars represent where these listening lines are. Jim Hoyle and Jeremy Holden have recently been working with Bruce on getting there will be, in fact, I think next week, tagging cisco in the Bay of Quinte to answer the question, how much exchange is there between the Bay of Quinte and the lake? Are these fish a separate population, or are they moving between the lake and the bay? It also might help us identify where these fish are spawning in the Bay of Quinte. Again, it's an important spawning population. We know that. It's been that way for centuries. And we'd like to find where they're spawning and perhaps focus on those areas, have the U.S. Fish and Wildlife Service come up and conduct mapping in those areas and identify how that spawning habitat compares with Chameau Bay and Thunder Bay, and look at the spawning habitat and quality on a Great Lakes wide basis. Ellen is going to expand that work and look at genetics and habitat, look at hybridization, potential hybridization between cisco and lake whitefish, look at this genetic similarity to the Bay of Quinte, and then expand that habitat work, as I said, to the other sites in the Eastern Basin. Recently, we're interested in, now that we're stocking those fish, we want to be able to evaluate the success of these stockings. USGS has been working with marking these fish with OTC and calcine, and they've had some success. This is just showing showing different bony parts of the fishes, and the marking does seem to be working. They've been differentially marking bloater, which you'll hear more about in a few minutes from Steve, but also cisco, and they're marking different life stages as well. So summary and future direction. Cisco are persisting at low levels, mostly in the Eastern Basin and the Bay of Quinte. There are positive signs of recent strong year classes and increased catches and assessment netting. Advances by USGS and cisco culture have really been tremendous. I just want to acknowledge Jim and his vision, and through Steve and Jim's leadership and making great strides towards this restoration. But there's also a plan by U.S. Fish and Wildlife Service to commit hatchery resources to Cisco restoration and take it basin-wide, which is also excellent news. As I said, there's new research to understand movement, habitat, and genetics of Cisco. USGS and DC plans for a new open lake midwater survey. So now that we have fish in the system, we need to begin establishing, or at least considering, changes to our assessment programs to try to track success of these stockings. Working on a restoration and management plan draft. And again, these partnerships, which continue to grow and facilitated by GLFC, continue to make great strides in restoration of our Cisco. That's it.